Today, we're going to break down an architecture that isn't just clever, it's a genuine masterclass in how to build a frugal, high-availability system in the cloud. We're talking about the Softoboros Stack, and trust me, it challenges some very, very expensive assumptions about the right way to do things. So let me just start by asking you a question that, well, it probably sounds a little ridiculous. Can you actually build a system that can survive an entire data center failure? We're talking true high availability for less than you spend on coffee every month. I mean, that sounds impossible, right? Well, believe it or not, the answer is yes, this architecture can do it. And in this explainer, we're going to tear it down piece by piece and show you exactly how they pulled it off. It all starts with this core idea, this philosophy you could call cloud sovereignty. Instead of just defaulting to whatever expensive managed service the cloud provider pushes on you, it's about taking back control. It's about finding smarter, leaner, and just more efficient ways to solve these fundamental problems yourself. And this table right here just lays out the problem perfectly. Let's just take task scheduling, something every system needs. The typical enterprise way, you're looking at something like Amazon's MWA, and that starts at a staggering $350 a month. Okay, so what about serverless with Lambda? Seems cheap, sure, but then you get hit with timeout limits and all sorts of dependency hell. Then you've got the stateful path with step functions, which is powerful, but it can lock your logic into a proprietary system. And then you have the Softoboros approach. The cost? It's basically zero. It's a sunk cost because it just cleverly piggybacks on infrastructure that's already running. How cool is that? All right, so let's meet the cast of characters in what they call the Softoboros Zoo. First up, you've got WebSlinger. That's the front end. Then there's Dumbo, which is their PostgreSQL database. RabbitMQ handles the message brokering. Worker takes care of all the background processing. And then there's the real star of the show, Red Queen, the utility core where all the magic really happens. And this brings us to the first, just absolutely brilliant move in this whole setup, the Red Queen service. This thing isn't just one service. It's basically the central nervous system for the entire stack. The strategy behind it is something called a hyper-converged utility layer. Now, I know that sounds like a super technical buzzword, but the idea is actually incredibly simple and powerful. Instead of paying for a bunch of separate, expensive cloud services, like a NAT gateway so your servers can talk to the internet, a dedicated scheduler, logging tools, you just collapse all of those jobs into one single, ultra-efficient component. And that component is Red Queen. But that brings up a classic problem, right? One as old as distributed computing itself. How do you make a custom component like a scheduler highly available? You need to run a task once and only once. If your one server running the schedule fails, you miss jobs. But if you run two servers to be safe, you might run every job twice, which could be an absolute disaster. This is where their queen versus knave protocol comes in, and it is so elegant. It's a hot shadow model. You have two Red Queen nodes. The queen is the active one, firing off tasks. The knave is the standby. And here's the genius part. It's running the exact same schedule in memory, but it never actually executes the final step. It's just shadowing the queen's every move. They use a super simple lock in DynamoDB to decide who's queen. If that queen ever misses its check-in, the knave sees that the lock has expired and it instantly promotes itself to queen, taking over right where the other left off. And get this picture says it all. That entire sophisticated high-availability system, the queen and the knave, it runs on these tiny T4G.nano instances. These are some of the smallest, cheapest virtual servers you can possibly get from AWS. The whole system is so lightweight, it just sips the idle CPU cycles from the machines that are already there to handle network traffic. So the takeaway is just mind-blowing. You get an enterprise-grade, highly available scheduler for, effectively, free. Okay, so that's scheduling sorted. But now let's talk about the really hard part, the part that's usually the most expensive in any HA setup, the stateful database. For their PostgreSQL cluster, they use a custom strategy they call Dynatrony. And the whole philosophy is captured in this fantastic phrase, static storage, mobile leadership. So what on earth does that mean? It means the data disks themselves, the EBS volumes, they never ever move. They are permanently attached to a specific availability zone. But the leadership role, the primary database that can take writes, that role is mobile. It can be passed over to a replica in another zone in an instant. So how do they manage that mobile leadership without running into that dreaded split brain scenario where two databases both think they're in charge? Well, the secret sauce, again, is the beautiful, simple power of DynamoDB. They use what are called conditional rights. To become the leader of a brand new cluster, the operation will only succeed if that lock doesn't exist yet. To take over from a failed leader, it will only succeed if the old leader's lease has expired. These operations are atomic, making it mathematically impossible for more than one node to claim leadership at the same time. Now, a system this lean and custom built could be an absolute nightmare to manage if it wasn't for a deep, deep focus on operational maturity. This is all about knowing with 100% certainty what code is running where at any given moment. The goal, really the holy grail here, is to create this perfect, unbroken, traceable chain. A chain that goes all the way from the moment a developer types git commit on their laptop to the actual virtual machine humming away in production. And here it is. The proof is right in the pudding. Just look at the names of these Amazon Machine Images, or AMIs. You see that? Right there in the name, you've got the timestamp and, crucially, the git commit hash. The unique signature for that exact version of the code is literally burned into the image name itself. There is zero ambiguity. So the pipeline is it's beautifully simple. A developer commits their code. AWS Code Build kicks off, automatically creates a new machine image, and burns that commit hash right into the name. When a new server needs to launch, it uses that specific versioned AMI. The end result? Perfect provenance. You can trace any running server directly back to the exact line of code that created it.
Okay, so we've seen all the clever architectural moves, the hyper-converged utility layer, the mobile leadership for the database, the traceable build pipeline. But what's the actual payoff? What does this all add up to on the monthly bill?
Now, when you look at a cost report like this, your eyes might jump to the total at the top. But that's just a snapshot in time. That's not the real story. The number that truly matters for our calculation is right here, the average hourly cost. The base infrastructure, that whole Red Queen system doing NATs, scheduling, and logging, it just hums along at a steady 8 cents per hour. So let's build this up from the ground floor. That foundational, highly available utility layer costs just 8 cents an hour. Now, on top of that, we add the actual application fleet. We're talking the web servers, the background workers, the message queue brokers, all running in a high availability setup across 2 different availability zones. That adds another 6 cents per hour. So you add it all up, 8 cents plus 6 cents, you get about 14 cents per hour for the whole shebang. You multiply that out, and the grand total for this entire resilient multi-AZ stack comes out to roughly $100 a month. That's it. It's just incredible. And that really leaves us with the big question to take away from all this. The Softoboros Stack isn't just about being cheap. It's a fundamental challenge to how we think about building things. It forces you to ask, what expensive best practices in my own cloud stack, what things that we all just take for granted, are really just waiting for a simpler, more elegant, and more clever solution? Thanks for joining me.